This is Griffin from the Math Learning Resource Center, and in this series of videos, we're going to be learning how to use a variety of tricks to manipulate trigonometric expressions. And these tricks mainly use trigonometric identities. And the way we're going to learn how to use these tricks is by going over problems. So in this first video, we're going to go over the following problem. Determine the value of the sine of the arc cosine of 2 over the square root of 5. So some things that will come in handy with this problem are the following facts. So one fact is that the arc cosine function is a function whose domain is from -1 to 1. It's a closed interval from -1 to 1. And whose codomain, or rather its range, in this case its range, is from 0 to pi. Note that the range and the codomain are actually two distinct things, but in this case the range of the arc cosine function is from the closed interval from 0 to pi. The second fact is that if x is in the closed interval from -1 to 1, then the cosine of the arc cosine of x is equal to x. Now, these two facts, I won't prove them here, but you can check out our videos on the inverse trigonometric functions to determine and to sort of get a feel for why these are true, and actually we'll prove why these are true in those videos. But for now, just take my word for it that these two facts are indeed true. Now, if we were somehow able to rewrite the sine of the arc cosine of 2 over the square root of 5 as an expression that was in terms of cosine of arc cosine of 2 over the square root of 5, we'd be in great shape, because check this out. 2 over the square root of 5 is a little bit less than 2 over the square root of 4, which is equal to 2 over 2, which is equal to 1. And of course, 2 over the square root of 5 is also greater than 0. That is, 2 over the square root of 5 is less than 1 and greater than 0. So that means 2 over the square root of 5 is in the interval from -1 to 1. So this means that the cosine of the arc cosine of 2 over the square root of 5 is equal to 2 over the square root of 5. So how are we going to rewrite sine of arc cosine of 2 over the square root of 5 as an expression that is in terms of cosine of arc cosine of 2 over the square root of 5? Well, we can use the Pythagorean identity. Check this out. This is our third fact that will come in handy. Cosine squared of theta plus sine squared of theta is equal to 1 for any angle theta. And in particular, if we solve for sine of theta, we're going to get sine squared of theta is equal to 1 minus cosine squared of theta. So that means sine of theta is equal to the square root, or rather plus or minus the square root of 1 minus cosine squared of theta. So this means, check this out, this means that sine of arc cosine of 2 over the square root of 5 is equal to plus or minus the square root of 1 minus cosine squared of arc cosine of 2 over the square root of 5. Now, by the way, writing cosine squared of theta is just a shorthand way of writing cosine of theta quantity squared. So this is equal to plus or minus the square root of 1 minus cosine of arc cosine of 2 over the square root of 5, quantity squared. But we know the cosine of the arc cosine of 2 over the square root of 5. That's just 2 over the square root of 5. So this is plus or minus the square root of 1 minus 2 over the square root of 5, quantity squared. And 2 over the square root of 5, quantity squared, that's just, well, when we simplify this, this is just equal to 1 minus 4 over 5. And 1 minus 4 over 5, that's the same as 5 over 5 minus 4 over 5. So this is equal to plus or minus 1, the square root of 1 over 5. And this is just equal to plus or minus the square root of 1 over the square root of 5, which is equal to plus or minus 1 over the square root of 5. Now, all we need to do now is to determine if it's plus or if it's minus. That is, if it's positive or if it's negative. But check this out. We know that the arc cosine function has a range that's from 0 to pi. So this means that we're plugging in to sine some angle from 0 to pi. And check this out. Based off the unit circle, any angle that's from 0 to pi will have its defining ray, sit on the top half of the unit circle. That is, all of these angles here, written in standard position, are in the top half. They lie exclusively in the top half of the unit circle. And check this out, since the sine of all these angles is the y value of each of these intersection points, it's the y value of each of these intersection points with the unit circle, this means that sine of any angle from 0 to pi is a positive value. And that tells us that this is indeed the positive square root, or rather the positive of 1 over the square root of 5. That is, it is positive 1 over the square root of 5.